Okay, this short video is about how to find the distance between 2 points on a graph. What does that mean? Well, if I have a point here at 2, 1 and a point here at 2, 4, 6, 8, 5, I'd like to be able to find the distance between those 2 points. And so we're going to look at that very quickly. First, I want to look at this segment right here. It goes from 1, 3 to 6, 3, and you can tell that has a length of 5. You can either look at the label here and say, oh, it's 5, or you can count 1, 2, 3, 4, 5. If I move it up to here, you can see now it's 4. 1, 2, 3, 4. If I go further out, over to, say, here, now it's got a length of 8. But even if I turned that off, you could still tell that it's a length of 8, because from 1 to 9 is 8. So let me say it again. From 1 to 9 is 8. Okay. If I look over here, the distance from, the distance from 3 to 6 is 3. If I move it up to here, the distance from 3 to 7 is 4. So what we're going to be looking at is, well, how do you tell this one here? You can see on the label it's 6.71, but how do you figure out what that distance is, and how do you use these numbers to do so? Okay? So here's what we're going to look at. Okay? I put a triangle on here that tells you the height and the length, sort of like a rise and run, but think of this as a right triangle. And what we'll do is say, hey, I can tell that that's 3 and that's 6 from the labels, or I can subtract to get that. Let me move it to a different space here. And now I can tell it's 2 and 6. And I could tell that this would be 2 even if I can't count, because I could say, well, the height from 3 to 5 is 2. And the length from 1 to 7 is 6. Okay? How does that help me? Well, now I can use the Pythagorean theorem, just the idea that you know about a right triangle. It says that if you take the two short sides, 6 and 2 in this case, and square each one of them, that'd be 4 and 36. When you take the square root of that, you get the length of the third side. Okay, so we're going to use that when we're calculating these. Let me switch over to here. So I'm going to look at this and say, well, I can either count the number of squares here, or I can say, well, 8 minus 2 gets me a length of 6 here, and 5 minus 1 gets me a height of 4 there. Since this is a right triangle, I can say, well, look, I know that 6 squared plus 4 squared has to be this distance squared. Okay, so I'll just calculate these things. Distance squared is 36 plus 16. That's a distance squared of 52. Okay. Well, nobody's going to believe you if you tell them the distance here is 52. It's not. Remember, that's d squared. So now you'll need to find the square root of 52. And square root. I'm looking for my square root key here. Oh, that's funny. Well, yeah, there it is. All right, 7.2. So that distance is going to be 7.2. So we'll do that with these things by simply taking if I have a point of negative 1, 2, up to whatever this is, 2, 4, 6, 8, 2, 4, 6, 8, 6. To find this distance, I'll just calculate this length by subtracting the x-coordinates. 8 minus negative 1 is 9. And I'll find this height by subtracting the y-coordinates. 6 minus 2 is 4. Now we'll use those numbers in the Pythagorean theorem. So 9 squared plus 4 squared has to equal d squared. So d squared is 81 plus 16. Add those together, you get d squared is 97. Again, don't get tricked into thinking that this distance is 97. It's not, but the square root of it is. So 97. Calculate what that is, and you're good to go. All right, that'll do it.